Good day, students. Hope all is well with all of you. Today I want to introduce you in one of our video sessions. I want to introduce you to a very important tool we all use in the laboratory. Nothing else other than the microscope. As a phlebotomist, or if you are MLA, and even if you are aspiring to do medical technology, one of the most important tools you will come across that you will use in the laboratory is a microscope. It has applications in different departments, in hematology, in microbiology, even in immunology. The microscope is a often used piece of equipment. Microscopes are very sensitive equipment. They are very easy to get out of alignment, and in an attempt to bring you up to par with a very important tool such as a microscope, I want to firstly introduce you to the basic anatomy of the microscope. There are many different types of microscopes, but this one is called a binocular light microscope. Binocular meaning there are two eyepieces. As you can see here, the eyepieces are adjustable. The eyepieces also come with a magnification of 10. So even before we attempt to magnify an image, anything that is viewed with this eyepiece is magnified by a times or a power of 10. So that's one of the first thing. The other thing I want to expose you or introduce you to is what is called the nose piece. The nose piece is an adjustable circular outlet where you can adjust your lenses. You will notice in the light microscope, lenses come in different lengths, and each of these lenses come with a different number on them. I will come back to the lenses in a short while. So this is the nose piece. This here is your stage. Your stage is where your slide or your image is placed onto. The stage has an adjustment capacity, what is called the X and Y adjustment, and this could essentially take your image or your smear or your slide, and based on the adjustment of your X and Y knobs, you can view or browse your image accordingly. What I want to also tell you about at this point is a very important aspect of the microscope, and I will show you the steps in microscopy in a short while so that you can carefully and systematically do proper microscopy work. This here at the back are your adjustment knobs. The larger circular one is called your coarse adjustment knob, and coarse adjustment meaning that turning this knob gives you a large access point of movement on the stage, right? We're talking about top to bottom, coarse adjustment knob. But on the outside, you're going to see another knob that is called the fine adjustment knob. This is a very important knob in your microscope, and this here is your fine adjustment knob. It is also located on both sides of the microscope. Coarse adjustment knob, fine adjustment knob. All right, so with that, also you've got your condenser and your aperture diaphragm, and these are adjusted as you do your microscope work. All right, now we, as in all microscopes, we've got our power knob that turns on the microscope, and we've got an adjustable capacity to increase or decrease the light intensity. All right, so I'm going to power it off now, and this here is the basic anatomy of your light microscope, your binocular light microscope. All right, now what I want to do is to step by step go through the recommended way for you to do microscopy, regardless whether the sample you are looking at is a sample of stool, saliva, semen, sputum, even colonies of a bacterial plate. It don't matter. Once you've got a standard slide to which a sample have been placed, you must use a particular format in microscopy. What you're looking at here is a hematology smear that was stained. I will use this for the demonstration today. All right, so looking back at the microscope now, what I want to go through step by step is the recommended way for us all to practice microscopy. To start with, the first thing you must do is put on your microscope. That's number one. Step one, power on your microscope. When you have powered on your microscope, then look at your eyepieces, and what you do with your both eyes open and not squinching and not partially like that, you keep both eyes open and you adjust your eyepieces until you see what I like to call one zone of illumination. That one zone of illumination is a circular illuminated area. Even though we are looking through two eyepieces, when we adjust the eyepieces to suit our eyes, you're gonna see one full moon. I like to refer to it as one full moon, one zone of illumination. That is when you know you have adjusted your eyepieces. You cannot adjust your eyepieces with the microscope powered off. You will not see the light and you will not be able to adjust it, all right, properly. It is common practice for any microscopist who is coming to use the microscope. Usually in laboratory environments, one technologist may call on another person to come and look at a sample or look at something there so that they could discuss it, etc. It is common where one microscopist would leave the microscope and bring his or her colleague to look at it, and every colleague that comes will adjust the eyepieces to suit their own eyes. Very important. Once you have located one zone of illumination, you notice no slide or no image have been placed on this stage as yet. That is step number two. Step number one, just to recap, you power on your microscope. Step number two, you adjust your eyepieces so that you see one zone of illumination using both eyes. I have just accomplished that. Step three is you take your coarse adjustment knob, students, your coarse adjustment knob, which is this one, and you turn it away from you. You turn it away from you, and in doing that, your stage goes up. But simultaneously, and you can call it step number four, you also adjust your nose piece to bring your lowest power lens facing down. The nose piece is adjustable, and you will hear a little click when your different lenses are moved into place. All right, now let's just spend a minute or two to discuss these lenses. We just mentioned that the magnification of the eyepiece is 10, but moving further now, when we talk about lenses, and I'm just going to turn it so that you can see, your shortest and lowest power lens is your ×4. Your ×4 is also called your scanning lens. As you go from ×4 and you notice the lens has automatically gotten longer, you have a ×10. From ×4 you go to your ×10. Your ×10 is called your low power objective. As you go from your 10, you go to your 40, which is this one, your 40, right? Your 40, and I'm just going to slacken it so that you can see it. Your 40 is what is called your high dry, all right? And then last lens, which is a very important lens, is your ×100, which is also called your oil immersion lens. This is the lens that require the use of what is called an immersion oil, and we'll talk about that just now. All right, so let's recap again. Power on, eyepieces adjusted to suit your eyes, as well as making sure you get one zone of illumination. Next step is you turn your stage. You're using your coarse adjustment knob and you turn it away from you. Your stage is gonna rise, as you see, and your stage is gonna rise. And as your stage rises, you also simultaneously you use your nose piece and bring your lowest lens down. There will come a point when the coarse adjustment knob is being adjusted where it will not turn anymore. It will not turn anymore, and your shortest lens, which is your ×4 or your scanning lens, is placed completely down. The stage will not go any higher. It will literally just reach a stopping point. This is the beginning of microscopy. This is the place where you would want to begin with. I will show you at the end of this session what are the don'ts, or what you do not do in terms of microscopy. So we have now turned our stage straight up using the coarse adjustment knob, and we have now our lowest lens down. I'm just gonna put this slide onto the stage, and this is your stage clip. This is your stage clip, and with that we put our slide there. Now you use your X and Y adjustment knob to actually bring your image through the light path. And in order for you to do that, you will see, right? Now just remember, your coarse adjustment knob has been turned straight up and your lowest lens is down. Your lowest lens is your ×4 magnification, also called your scanning objective. At this point, students, I want you to know you will not be seeing anything. If the image was stained using a particular staining method, you might see the background of the image. You might see a purple color, you might see a red, you might see a pink, but you will not be seeing anything because no fine-tuning or nothing has been done yet. The next step I'm about to share with you is very important. And before I do that, I just want to reiterate to you guys, coarse adjustment knob have been turned straight up and the lowest lens has been adjusted and is facing down. At this point, and only at this point, students and microscopists, at this point, what you do, you look at your image, because your eyepieces have been adjusted to suit your eyes and we are seeing one zone of illumination. You use your coarse adjustment knob. You use your coarse adjustment knob and you turn it. If we are focusing on my finger now, you would see how little you will have to turn it. You turn it slowly towards you until an image comes into focus. And therein now, from a place of nothingness, I have come and brought an image into focus. But because the ×4 is very weak magnification, I will be seeing the image very, very small. But I just want to let you know we have come into focus, or brought into focus, the image. We have now located our image. But I want to recall that I only utilize the coarse adjustment knob. So I'm going back to the place of where we were before. Coarse adjustment knob, turn and stage brought straight up. I will be seeing absolutely nothing except probably the background color of the smear or the image. All I do now, very importantly, is turn my coarse adjustment knob. My coarse adjustment knob a little bit towards me, and now my image has come into focus. At this point, the image will be small, but yet it is focused. Now, at this point, I want to introduce you to something called parfocal, P-A-R-F-O-C-A-L. What that means in microscopy, especially with microscopes, is that it is a term used to describe a microscope's ability to maintain its focusing capabilities even when lenses are changed and from one lens to the next. A good working microscope will have a good ability to maintain strong parfocal capacities. All right, so because this microscope is parfocal, I have located an image with my 4 objective. So now, even now, times 10 by 4, the image has been magnified 40 times. But now, students, I want to let you know, we want to magnify this image, and in doing that, all we got to do is turn our nose piece or flick our nose piece from 4 to 10. You actually would hear or feel a little click. What we have done here now, we have moved from 4 magnification to 10. Now, you will recall just now, I adjusted the coarse adjustment knob by turning it towards me. Now, students, very important, the coarse adjustment knob is no longer used. It is no longer used. All we are doing now, because of the parfocal nature of the microscope, we are just only using the fine adjustment knob, which is this little knob on the outside. This knob here, and why we call it a fine focus, is because a little turn in either directions is going to bring our image into more clear, crisp appearance. So I have just adjusted my coarse adjustment, my fine adjustment knob, and we have Now increase the magnification from 10 by 4 is 40. Now it's 10 by 10. The image is now magnified 100 times. So obviously what I'm seeing is a bigger magnification, a bigger image, but all I did was adjusted my fine focus. Very important. Just to recap here, the coarse adjustment knob is only used in the initial adjustment of your stage in microscopy. But now I'm not happy. I want to magnify this image a little bit more. So what I'm going to do now, I'm going to engage my nose piece and I'm going to go from 10 to 40. You will notice here that the times 40 lens is very close to the slide. It's very close to the slide. Now what we do here again, if you look at my finger, I'm just adjusting the fine focus knob slightly back or forth, and now my image is bigger, it is clearer, and I have not used my coarse adjustment knob since the beginning of adjustments. This times 40 is also, as I mentioned before, called the high dry. One of the most dangerous, unfortunate things that occur in microscopy is when technologists, trainees, assistants, anyone who utilizes the microscope, they sometimes get oil that is only supposed to be used in your times 100 or your oil immersion lens. They get oil onto the 40, and I'll show you how that could happen. Because these oil immersions come in dropper bottles or so, sometimes, and you notice, as I mentioned before, how close the times 40 lens is to the slide. When you want to magnify more, you've got to firstly kick your 40 out of position. Then you go from the back, students, or you come from the front and you administer or add 1 drop of your immersion oil. Your times 40 lens, which is your high dry, is free from any contact of that oil. Then you turn your nose piece in a clockwise direction, and what has happened here at a microscopic level, the lens, the 100 magnification lens, has formed a continuity with the oil, and then the oil has formed a continuity with the image for clarity. Now we come back again, we use our fine adjustment knob, and there now I have my image that is very big and clear. Now remember, initially I told you guys about condenser and aperture. As you go, it is important that all students of science, especially laboratory related sciences, know the anatomy and the function of the microscope. But for now, I just want to simply let you know, as you go from low magnification to higher magnification, you raise your condenser. And simultaneously, as you raise your condenser, which is this, there's another knob at the side here. You raise your condenser and you will see it is coming up closer to the bottom of the slide. You raise your condenser, and then also you increase your light intensity. What this does, it gives you a finished product that is really worth observation now. All right, so now what we have done here is covered the use of the microscope. You may ask yourself, when do we actually use the times 10, the times 40, which is the high dry, or even the oil? That will be looked at in another session, but for now I just wanted to utilize these few minutes to introduce you to the light microscope, one of the most important tools in the medical laboratory, its basic design and its function. Now I want to show you what pore technology is and what some persons, the method some persons employ when they've got to locate an image or they want to examine an image under the microscope. We're going to use this same slide, and you will recall that I said with the beginning of microscopy, your stage straight up and your lowest lens down. Then from there, we use the coarse adjustment knob and we turn it, as I mentioned, slightly towards you, the user, and an image gonna come into focus. What some persons do, which is very risky and you can break your slide in the process, is they don't do that. they start with their stage straight down. So they start there. Then they utilize and they flick into place any lens that they want to examine the image with. And what they do while looking at the eyepieces, they use their coarse adjustment knob, and I myself am hesitant to do it, because what will happen while you look in here and you're using your coarse adjustment knob and you bring in your stage up, what happens is, because the lens is so long, somewhere very soon that lens is going to come in contact with the slide, and if you are focusing here and you're using your coarse adjustment knob, you will actually impact your slide. Your slide could break, a very important smear could be lost, and then you can also damage the lens in your microscope. This is not the way. So you taking your stage straight down and looking at your eyepieces and turning it now upwards is not the proper way to do microscopy. So that is one very important tool. Apart from that, general housekeeping dictates that safe wipes are used in terms of lens wipes, and there's a lens cleaning solution. It is important that we sanitize and we clean our microscope at the end of every work session, and that microscopes are covered, powered off, oil is removed with lens paper, etc., so that we finish off and clean up our business. And the best way to store your microscope when not in use is to put back in your lowest lens down, so that just in case the stage gets adjusted in any small way, you will not damage your lenses. All right, so students, this is one segment of tutorials aimed at enhancing your abilities in the laboratory, and this is your very basic and fundamental introduction to the microscope, its use, and its basic anatomy. Hope you guys enjoyed this little session. Keep well and look out for additional ones to follow.